Here we go. We are still in Unit 4, still on Lesson 4. This is the second day, the second half of this lesson, broken into 2 days, and the previous video was day 1. We are going to talk about the equations for special cases, lines that are special lines, and they're called special cases because we're talking about vertical lines that go straight up and down and horizontal lines that go straight across from left to right. And because these lines are special, they're not at an angle really, their equations look a little bit different. The linear equations for vertical and horizontal lines can be a little bit tricky if you overthink it. Do not overthink it. Okay, I'll try to get through this, as always, as fast as I can. Vertical lines are lines that go up and down. So sometimes it can be tricky when we're looking at the coordinate plane that has a vertical line or a horizontal line. It can be hard to see it because it looks like it's part of the x-axis and y-axis. Like sometimes our eyes need to find, wait, which one is the y-axis? Is this the y-axis or is this the y-axis? So try to look for the darker line or the line that has the darker arrows on the ends. So in this case, this is our vertical line right here, whereas this is our y-axis, okay? So we're going to be focusing here on the red line. It says here, which I think is a little confusing, but I'll read it. A vertical line is written, it should say that the equation for a vertical line is written in the form x equals a, where a represent the line's x-intercept. Mumbo jumbo. Here's what it comes down to. On a vertical line, a line that is straight up and down, I want you to think about the ordered pairs. For example, this point right here is the ordered pair 3, 3. And the point below it would be 3, 2. And the point below that would be 3, 1. And moving down, 3, 0. And we could keep going. But what do you notice in these ordered pairs for a vertical line? I hope you notice that the x value is remaining constant. We're never traveling right or left. We're always staying at 3, 3, 3, 3, 3. The change is happening in the y. For the y here, we were up 3, then we were only up 2, then we were only up 1, then we were 0, then we were down 1. So the y is what's changing. The x value is what's holding constant. So if you're going to go write the equation for this line, it's as simple as this. X equals, and then you just write the number of the x-intercept, which happens to be positive 3. Because what we're telling the viewer or whoever is reading our equation, we're telling them draw a line where x is always equal to 3. That means in every ordered pair, x is 3, x is 3, x is 3, x is 3, x is 3. I don't care what you make y. Y can be anything. It could be 50. It could be positive 5,000. It could be negative 1,000,000. Y can change as much as you want it to change, but x always has to be 3. So x equals 3. No matter what y is in your ordered pairs, x is 3, x is 3, x is 3, x is 3. So where x is 3, it is a vertical line passing through that point on the x-axis. Okay? Now you can apply the same rationale to horizontal lines. Again, look, this one is actually the horizontal line I want to focus on. It's the darker line with the darker arrows. Now let's consider these ordered pairs. For example, this ordered pair right here is negative 3, negative 1. And this ordered pair is negative 2, negative 1. This is negative 1, negative 1. This is 0, negative 1. That one 1, -1, and 2, -1. So what you should notice here in these ordered pairs is that the y stays constant and the x is the one that's changing. So the equation for this line is y equals a, where a represents the line's y-intercept, which is always -1, -1, -1, -1. So all you have to tell the reader is draw a line where y is always equal to -1. That's it. It doesn't matter what your x value is. X could be +1, +2, +3, +4. X could be anything in the negatives, right? X can change as much as it wants, but y is holding constant at -1. So the easiest way to do it is to find the y-intercept and write y equals -1. And that actually then is a horizontal line. It's not that bad unless you overthink it. And I know what happens. I'm telling you what's going to happen because I've been a teacher long enough to know. Kids are going to see equations like this, and they think, oh, that's a vertical line because it's a y. And y always goes up and down, right? Like the y-axis goes up and down. And that would be a normal thing to think. But it's backwards. If the equation says y equals something, that is a horizontal line. Whereas over here, when it said x equals, we always think about x as being this axis, right? A horizontal axis. It is of the horizontal axis, but as a line, it's a vertical line. It's like backwards day, okay? And I'm telling you, that's where kids mess up. They always think this is a vertical line, and they always think this is a horizontal line, and it's actually flip-flop. Okay, let's try some. I've already over-talked it. Number 1, this is the line we're focused on. I notice it's crossing through the x-axis right there. So the equation for this line is x equals -2. Honest to God, it's that simple. That's it. Because no matter where you are on the y's, you're always -2 for the x. -2, -2, -2. Number 2, here's the line we're focused on. Here's the intercept. It's a y-intercept, so it's y equals 1, 2, 3, +3. That's it. That's the equation. We're saying on this line, no matter what x is, y is always 3. We're always up 3. We're always up 3. We're always up 3. Okay? Let's do a couple more. Number 3, our line is way down here. Here's the intercept. It's a y-intercept, so it's y equals -1, 2, 3, 4, 5. That's it. Y equals -5. That's the equation for that line. Look at this guy. What? Well, it's a vertical line, right? It actually is on one of the, it is on the y-axis, but that's okay. It is intercepting the x right here. Where x is 0. That's it. X equals 0. There you go. Let's see the next page. What if they go the other way? What if they give you the equation and they want you to graph it? You can do that, you guys, because you're smart. You can do it. Check this out. It says graph the vertical or horizontal line. All right, they're telling you y equals -5. So if you want to, you could think of ordered pairs where y is always -5. You could think of it this way. I don't care what you put in for x, y is always -5. You could do this and plot these points. Or if y equals -5, you find the y-axis, you find -5. Holy moly, this is like micro tiny. Holy cow, 1, 2, 3, 4, 5. That is so tiny even for me. Suffice it to say, it's down there. Now think of a line that passes through that point. It's a horizontal line. Or plot your points. X of 1, Y of -5. 1, -5. 2, -5. 2, -5. -1, -5. And 0, -5 I already plotted. Like I said, it is a horizontal line passing through the y-axis where y is always -5. Okay? How about this one? Draw a line where x is always -1. Where is x? This is your x-axis. -1, right there. Think of a line passing through that point. It is a vertical line where no matter where you are, up or down, you are always moving left 1, left 1, left 1, left 1. Ordered pairs would look like this. And you could put anything here. No matter what y is, x is -1. Okay? A couple quick questions to finish us up. Just kind of some higher order thinking stuff. See if you can put this together. It says, what is the slope of the line where y is -5? Well, what kind of a line is that? Where y is -5. That is a horizontal line. What is the slope for a horizontal line? It's 0, because horizontal lines have no slope. All right, number 12. What is the slope of a line if it says x is -2? X is -2, that is a vertical line. What's the slope of vertical lines? Undefined, right? Like a cliff. What is the slope of the line where x is 0? Well, if x is 0, again, it's this kind of line. Undefined, because it is a vertical line. All right, we're going to stop there. Keep this one nice and brief. I hope you understand the difference between vertical lines and horizontal lines, also known as special cases. Some kids are able to pick up on it really quick because they don't overthink it. Other kids will struggle with this because they cannot get over it in their brain that something that has an X is actually a vertical line, whereas something that has a Y is actually a horizontal line. It's backwards of what your brain has been trained to do for all these years. So in that case, you might be a kid who needs to make the ordered pairs. And there's nothing wrong with that, whatever it takes to get it into your brain, okay? Thanks for watching. We'll talk about this in class in our Google Meets and be in touch as needed, all right? Take care. Bye-bye.